Okay, so example 3 is where this starts to get a little bit interesting. So we've got a rod here. I've highlighted the pivot point. I'm just going to demonstrate why that's really important. So the pivot point shows you where the rod is fixed. So the pivot point would be here. And we've got this force here, the 3 newtons at the end would turn it. And you can see this is going to turn it anti-clockwise, right? That 3 newtons is pushing it up there, which is anti-clockwise. So I've coloured that in pink. The 4 newtons, because it's on the other side of the pivot, is going to pull it down. But look, the effect is that you still turn it anti-clockwise. So that 3 newton force and the 4 newton force are both acting on it anti-clockwise, so I've coloured them both in pink. This one at the end though, the 5 newton one, if we demonstrate that, we can see that that is turning it the opposite way. That's turning it clockwise. So that's why I've put that one in blue. So that's why the pivot point is so important, because depending where the pivot point is will show you which forces agree and which disagree. Even though this 3 newtons looks like an up one and this 4 newtons is a down one, because they're on the other side of the pivot, they're both turning it in the same direction. So it's really important before you start, you think about which ones are going in each direction. We're now going to work out how much each of those moments are affecting it. So I'll start with the 3 newtons. Remember, it's force times distance. So 3 times 1 is 3 newton meters. And we don't have to do anything with the angle because it's perpendicular already. Remember, if it's perpendicular, it's fine. If it's not perpendicular, we need to resolve it to the perpendicular. The second one is this one here. This is 4 times 1, which is 4 newton meters. Right, and they are both, as we've already said, going to turn it anti-clockwise. Meanwhile, right, this blue one is right at the end, and we know it's going to turn it clockwise. The force is 5, and the distance, be careful here, it's not the distance from there, it's the distance from the pivot. Always the distance from the pivot. So it's 3 meters. So this is 5 times 3, which is 15 newton meters, and we've said already this is clockwise. So the question actually asks us for the resultant moment, and actually the resultant requires us to resolve and think about who has won. So you've got different forces trying to turn them in different directions. Obviously some of those forces are going to cancel out with each other, and we'll get an overall direction of motion, and it'll turn. You can see the clockwise is 15 newton meters, and if we add together these two, it's 7. So obviously there's more of a force turning it clockwise than anti-clockwise, which is mainly because of the length away. So that's where it becomes really important. If you're trying to turn something and you're in your sort of tug of war trying to turn it, you want to pick a point to turn on that's as far away from the pivot as possible, because you'll have more of an effect. You'll have more of a turning motion if you're further away from the pivot. That's kind of the key idea in moments. So we've got 15 clockwise, but this is going to get cancelled out a little bit by the 4 and the 3 turning the other way. So this is 8 newton meters, and we've got to state the direction clockwise. So the blue one is going to overpower these two, and we'll get an overall force turning it of 8 newton meters to the clockwise direction.